Welcome to our Chapter 5 video. This one's dealing with the binomial distribution. It is a special discrete probability distribution. It has all the same properties, all the same formulas apply, but it is special, and the specialness of it makes some calculations much easier, and it is more applicable in many cases. So with the probability distribution, a binomial distribution, here's an example. You can print this off of the blackboard if you need to. Experience has shown that 1 out of 200, which is a 0.5%, or 0.005, of all CDs produced by a machine are defective. Quality control randomly tests 20 of these CDs, compute each of the following. And this is a very lifelike example, something that is done. With this, I'm going to break this into two different videos. I'm going to do part A and B first, and then the calculating probability parts C and D as a second part of the video. So first of all, part A, creating the binomial distribution, X binomial. And the text will tell you the different requirements to be binomial, but if you can make this particular setup, it will have met all of those requirements. So first of all, if you can identify N, that's the number of trials. In this case, they tested 20. That's the fixed number of trials. If you can identify them as a fixed number, that's the first part of a binomial distribution. If it just keeps selecting CDs an unlimited number of times, then it can't be binomial. You have S and F, which stands for success and failure. These need to be written in terms of words. It describes what you're going to call successful for this experiment. In this case, since the part down at the bottom is asking for probabilities of defectives, it would be a good idea then to say that success is actually a defective CD. Connotation would say defective would be a failure, but for our probability, defective is considered success. Then non-defective would be failure. Two different outcomes. That's the bi part of a binomial. Two chances only. Then you have P. P is the probability of success. In this case, 0.005. That's where the number part comes in, the probability. S is the word, the description. P is the actual value. Then Q, well, that's the complement. 1 minus P. Complement was used in chapter 4. 0.995. Probabilities are fixed on each step. X. X represents the number of, in this case, defective CDs. The text will show you as I can have 0, 1, 2, ... in this case up to 20. I prefer to use the word description where X is the number of, in this case, defectives. to use a word description so that when I get ready to calculate probabilities, I know what that X represents. So if it asks down in the bottom, what's the probability that the 5 are not defective, that would mean 15 are defective and X would be 15. So that word version of writing that to me is helpful. And then last, you have the probability function itself. Default formula in choose X, P to the X, Q to the N minus X. That's just the formula. Our particular one N is 20, so out of 20 different items, selecting X times 0.005 to the X, and then 0.995 to the 20 minus X. So that creates the distribution. The formula, the function has to be included as part of the distribution. Identifying all of the different parts is part of the distribution. Everything you see there in red creates the distribution. For part B there, the mean and the standard deviation. The mean. Same notation as before, mu, because it is population. Mean, remember, is like an expected value. N, P. Out of 20 items, I would expect 0.5% of them to be defective. NP, which would be 20 times 0.005. That gives us a 0.1, 1/10. The standard deviation, it is an equivalent formula to the one that we saw in the earlier video, but calculating it by that technique would be extremely difficult, extremely time-consuming. It's still a sigma, it's still a square root, but there's a nice short NPQ. Our example, square root of 20 times 0.005 times 0.995. Remember parentheses. Multiply, then square root. This particular example, 0.315. So that's calculating the mean and standard deviation. It's creating the distribution. Common errors for this last part, not including the parentheses or forgetting to take the square root. So that's calculating mean, standard deviation and creating the binomial distribution.